door 3. He opens door 6 and he closes door 9. Boy 4 comes. He opens door 4 and he opens door 8. Boy 5 comes. He closes door 5 and he opens door 10. He closes door 6 and nothing else. B7 closes door 7. E8 E8 closes door 8. E9 E9 opens door 9 and B10
Video turned off.
Video is off.
it's on now.
It's okay.
Yeah.
Please move it to right.
You can see both the borders, right?
It's fine. Yeah, it's
Yeah.
fine. Now it's fine.
Okay. Okay, so where were we at? We were at B10, right? So B10 closes this door. So now let's look at the doors which are closed. Now door number 2 is closed. Door number 3 is closed. Door number 5 is closed. 6 is closed, 7 is closed, 8 is closed, and 10 is closed. So the doors which we have opened are 1, 4, and 9. Now what do these three numbers have in common?
They're all
Perfect squares.
they're square numbers.
They are perfect squares.
Okay, they are perfect squares. And now can anyone explain why this happened?
Yes, I think I can explain.
Okay,
Can I?
yeah, go on. Yeah, sure.
It is that the number of boys that open or closes the door is just the number of devices of that number. So
Yeah,
if the number of boys is odd, then the number of devices has to be odd, and so the number has to be even, and only then can the door be open.
Yeah, exactly. So if you take any non-perfect square number, you can always pair up its factors, right? So if you take the number say 50, you can always pair up the factors. You have 1 into 50, you have 2 into 25, you have 5 into 10. So you can pair up these factors. So the number of factors is an even number. If you take a perfect square, like say 30,
Bhaiya, your video stopped.
And it is showing that the internet connection is slow.
Video is loading. It got frozen.
Yeah.
this would have been complicated to see if you were dealing with block. But since we have reduced this problem to 10 blockers, it is
Your
quite obvious.
video got paused in the between. Can you please repeat from number of divisors?
It again got stopped.
From the part where someone told the reason, means why is that the reason, that one?
Okay. So basically, perfect squares have an odd number of factors. Can we agree with that?
Yes, Bhaiya.
Yes.
So if we consider each locker, the number of times they are opened or closed is the number of factors that they have. Right? And that is why the perfect square number.
The number of times.
What? No, we are just dealing. dealing with the number of factors it has, right? Because, okay, let's see 6. Now 6 is first at 1 because it's divisible by 1, and then it's closed at 2 because it's divisible by 2, opened at 3 because it's divisible by 3, and then it's closed at 6 because it's divisible by 6. So the state of the lockers are only changed when the boy is a factor of the locker number, right?
Yes.
Okay. So now if we consider our original problem, so in our original problem, we had 100 lockers. Now from 1 to 100, we have 10 perfect squares, right?
Yes.
10. So these 10 lockers will be open, and therefore the number of closed lockers will be 90, right? So
Yes.
this
Yes.
is a very useful problem solving strategy. Dividing the problem, breaking down the problem into a smaller one, solve that, and come back to the original problem. We'll use this a lot when we are dealing with counting problems. And now another fun puzzle kind of. So
Could you just explain it again, please?
okay, so consider locker X. X is from 1 to 100. Now the number of times we are opening or closing X is the number of factors it has, right? So if you take a perfect square, it will have an odd number of factors, and if you take any other number, the number of factors will be even because you can break the factors into pairs, right? And that's why only the perfect square number lockers will be open. Is it clear now?
The numbers which are getting squared, and whatever the total count, it can be opened, and the remaining one we have to subtract and get the number of being closed.
Yeah,
Right?
yeah. Okay. So we'll move on to our next problem, which is a kind of puzzle actually. Okay. Okay. Right. So we have 9 points like this. Using only 4 straight lines.
But I have done
Can
this
you?
problem.
Okay, yeah. So let the others try then. So
I have also done it.
so using 4 lines, connected lines, continuous lines actually, like something like this. It shouldn't break. So using 4 connected lines, go through all these 9 points.
But you're done.
Okay, cool. Let the others try.
So we can just connect the last points, vertices.
Can I say?
Let the others try for a
Uh,
minute, then you can say.
if you have done it
Can we
earlier,
connect the
then
last?
please
I
don't.
have not done it earlier. I
Can
am
we
trying it
connect
now.
the vertices? Can we connect the vertices of that like square form?
Yeah. That's what you have to do. You have to go through all these 9 lines using 4 straight lines.
Will it
What does
4 straight.
the length of the line be? Is there any
It's not specified.
restriction?
No, it's not specified.
Like it has to go through all the dots.
Yeah.
Basically, you have to draw 4 lines to connect all the dots, and you should not lift your pen.
And the lines length should be same.
No
There is no
restrictions
such
on.
restrictions.
Two ways. One is directly by consecutive, starting from the middle, and the and the method as well.
Okay, so I'll give you guys some more time to figure this out.
I can see a 5 in this figure.
Okay, if anyone has a solution, you can share your screen with us.
Will it be 4 lines?
Yeah, using fold lines.
Can you just give 2 or 3 minutes to think of it?
Done.
Okay, so can you show your screen then?
Bhaiya, how will we show our solution?
You can turn on your video.
Or you can share your whiteboard also.
Yeah, you can do that. Okay.
Can I share?
Yeah, sure. Uh, yes, why not?
You have to lift your pen once to draw this shape.
Yeah,
The original problem
and it's
told that
also
you
5
cannot
lines.
lift your pen.
So yeah,
Bhaiya, can I show?
yeah. Go ahead.
Is overwriting allowed?
Bhaiya, where is the whiteboard options, Bhaiya?
Oh, whiteboard option. I think if you click
In
on the
the
3 dots and
upward
share
arrow, in
content.
the upward arrow.
In share content, it's only showing PowerPoint, WhatsApp, and it's not.
Is overwriting allowed in this sum?
In the WhatsApp group. Can I share the
What do you
solution
mean
in the
by
WhatsApp group?
overwriting?
Overwriting means without lifting the pen, can we retrace a line?
Okay, but that will be considered as 2 lines. So that's suboptimal. Okay, so I'll share the solution now, and we can move on to more.
Will it be
Yeah,
something?
yeah, sure.
Can it extend through the figure?
What?
Can the line extend through the figure?
Yeah.
Bhaiya, I'm showing it on that.
Satire length.
Whiteboard.
I did the same.
Yeah,
Bhaiya,
that's
this was also the same, Bhaiya.
I also did.
yeah,
And I
that's
did.
perfect. So in this problem, you literally had to think outside the box. So, okay, can you see now? So yeah, just what he did. So using fold line, you have connected all the 9 vertices. So this is another strategy which is essential while solving combinatorial problems, thinking outside the box, and we'll be dealing with the okay. So now we'll get into counting. Now, all of you know what counting means, right?
Hello.
And
Oh, come on, you.
you hello.
Problems connecting to network. Dude.
Please mute.
Okay, could you please turn off your mic?
That's why it's not unmuted.
Okay, so proceeding. Counting. So counting is just like 1, 2, 3, 4, 5, 6. That's counting the set of natural numbers. Now, when we're dealing with counting in Olympiad problems, what we actually have to do is not count. We try to solve counting problems by not actually counting like 1, 2, 3, 4, 5, and devise shortcuts to actually solve them. Now, before we move on to problems, we just okay. Could you please switch off your mic, wherever that is.
Can you please say from we all know what counting is, because I missed it because it was raining in my area. That's why.
Uh, is it possible to actually mute someone?
Excuse me.
Yeah.
I wanted to say that can you please repeat from we all know what counting is, because it started raining in my area, so I had to leave the call.
Okay. So we haven't done anything major yet. So basically, a counting problem in Olympiad math.
Someone has started screen sharing.
Okay, could you please stop that? Okay, so you guys can see the blackboard.
Excuse me, someone has started screen sharing.
You can pin Ahir's screen.
That is Pulkit Khanna. That is Pulkit Khanna.
Okay, Pulkit, could you please stop screen sharing now?
Or we can
There's
our
some problem happening. I do not know how to stop it. It's not stopping even.
Okay, sure. So, okay. Continuing. Olympiad counting problems actually involve solving them without counting. So we'll move on to that later. The basic two principles on which counting is based are the addition principle we have it, and we have the multiplication principle. So while starting out with counting, a lot of people have this dilemma, like when to count, when to add, and when to multiply. So let's take a simple example. Suppose you go to Burger King, and now on the menu you have 5 burgers. Okay, I'll just write it. So suppose we have 5 burgers. We have the 3 kinds of wrap, and we have 4 kinds of drinks. So denoted by B, W, and D. Now, suppose you're dieting, right? So you're only going to choose one of these items. In how many ways can you do this?
60.
No, we are just selecting one item. Only one of
Sorry, 12.
12, right?
See, 1 plus 4.
Because we are selecting one item from out of 5 burgers, 3 wraps, and 4 drinks. Only one from these 12. So obviously you can do it in 12 ways. So the answer in this case is 5 plus 3 plus 4, 12.
Excuse me.
Yeah.
Sorry to interrupt, but the person sharing is still sharing his screen and I am unable to see the whiteboard.
Okay. Does anyone have any solution to this?
I don't know. He's not
Bhaiya, we
sharing
can
anymore,
directly
I
play
guess.
your video.
And
First it
pin
was
your
coming, but
video.
I picked your video instead of his. Yes, there must
Is
be a
he yet
space in
sharing
the
the screen
whiteboard.
now? I cannot see it on my screen. He's not sharing, I guess.
Okay, whoever is sharing, could you please stop? Like take up a pen and paper and do your stuff, right?
He left the meeting.
Okay, cool. So proceeding with this, we are selecting one item here from 12.
Video got
Yes,
off.
your video got
Yes.
Okay, is it visible now?
Bhaiya, it came, then it just went off.
Yes.
It's not visible here.
Now?
Now it's visible.
Now it's okay.
Now it's
Visible, right. Okay, so proceeding with our problem, we had 5 burgers, 3 wraps, and 4 drinks, and we are selecting one of each type. Now, in how many ways can you order?
12 ways. What? Can you repeat the question, please?
5 into 3 into 4.
Yes, 60 is the
Okay.
answer.
60, 60.
I'll just repeat the question once more. So we are
20.
now we have 5 burgers, 3 wraps, and 4 drinks, and we are selecting one burger, one wrap, and one drink. So in how many ways can we do this?
60.
Factorial.
5 into 3 into 4.
Will
Okay,
it be
5 into 3 into 4. So you guys are saying it's 5 into 3 into 4, which is 60. Right. So some of you might be asking why we multiplied in the second one and added in the first one. Why we added in the first one is quite obvious, because we had 12 items and we're selecting one. And I'll just explain why we're multiplying here. So suppose instead of 5 burgers, we had only one type of burger. So we have one burger, 3 wraps, and 4 drinks. And now we ask the same question: how many ways can we order one burger, one wrap, and 4 drinks? So the answer now is 12.
জানলা খোলা ছিল, পুরো মাটি ভেসে গেছে, আর বুঝিনি তো।
Okay, could you please switch off your mic?
Radha, can you tell how did it come 12 instead of 1? Because we are going to take all of them.
Okay, we are going to take
One of all of them.
Yeah, one of all of them. Okay,
So it
suppose
will be
the
one
answer is X. Let's not put any number to this right now. So suppose the answer is X if we have one burger, 3 wraps, and 4 drinks. Now suppose we have several combinations. And now suppose we change one burger to 3. So isn't it obvious that the number of combinations will get multiplied by 3? So suppose we have wrap 1, wrap 2, wrap 3. And we have drink 1.
Excuse me, Bhaiya.
Yeah.
Someone is sharing
it's
the
screen
screen and
sharing.
I cannot pin the screen actually. It's showing that
Okay.
Ayush Kumar is sharing or something.
Okay, Ayush, could you please stop?
But yeah, actually, I was not sharing. That person was sharing, and when he left, I accidentally I shared. I've done nothing.
Okay. Is it solved now? Or is this
Again, someone is sharing. It's
Actually,
somehow
nobody is
shortly,
sharing.
I guess.
It's automatically transferred. I don't know why.
Because the presenter is being changed. That symbol is being changed continuously.
Is it still
Still we can do is here
Rishabh Chakraborty is sharing.
you can just select the arrow and your video will come.
We can do anything on
Video
that
because the
board.
video cannot be seen.
We can
Okay.
between option and
I try to clean this.
I hit the other screen.
But the ones who are doing in the phone, how will they pin it? How will they pin it?
Is there
Put
any
the phone.
floating
You need to
window on your
put the
side?
phone in landscape mode, and then you need to double tap on hide others video.
Yes.
Yes.
Okay, just let me know when you have solved this problem.
The new problem is that your video can't be seen.
Yeah. Okay, so
Sharing
can
her.
you see it now?
Yeah,
We
yeah.
could see it for a brief.
Okay, just one second. Okay. Okay, so we had three. Okay, we changed the problem to one burger, right? So we have one burger, three wraps, and okay, let's to make this simple, have two drinks. Now, why were we multiplying in the second situation, right? So let's label the wraps as W1, W2, W3, and the drinks as D1 and D2. So how many combinations of wrap and drinks do we have? Let's just list them out. So we have W1, D1, W1, D2, W2, D1, W2, D2, W3, D1.
We can understand you, but the screen is really very
Six
huge.
combinations.
Okay. Okay, my this meeting will end in 5 minutes, so you guys will have to rejoin soon. Okay, so we'll just complete this now. So we have 6 combinations here of wraps and drinks. Now, if we have one type of burger, you can obviously you can just add B to all of them, right? And these are all of our 6 combinations. Now, if you had 2 types of burgers, you could add any of those 2 to these 6 combinations, and it would have given us a total of 2 into 6, right? Because we could have B1 W1 D1, B2 W1 D1, we could have B1 W1 D2, B2 W1 D2, and we could proceed like that. So the number of combinations got doubled. Is it clear?
Your screen is hazy.
Yes, it's clear.
Okay, it's clear, right? So if instead of 2 now, we had n burgers, n being a natural number, then we could have B1 W1 D1 up to Bn W1 D1. So we could have n combinations from here, n combinations from here, n from here, n from here, here and here. And this would have,
So would it be tutorial?
so it would be 6n, right? Because we have n. So basically it's 6 into n. So do you guys understand why we are multiplying now?
Yes, Bhaiya.
Yes, Dada.
Yes.
Cool. So we'll move on to
We
permutations
can
and
understand, but your screen is very hazy.
okay, I'll try to fix that.
Your video is turned off, Ahir.
Yes.
Okay, you should be able to see now. Can you see
Yeah,
it now?
it's visible.
Yeah,
Okay.
it's visible.
So these are basically the addition and multiplication principle. Now we'll try to solve a few problems based on this. Suppose you have two non-negative integers x and y such that x square plus y square is less than equal to 6. X and y are integers greater than or equal to 0. So has everyone joined in?
$54 people have joined. Last
Bhaiya,
time I
your
think the
video
count
is
was
coming.
around 60.
Bhaiya, your video
Yeah,
is coming
yeah, it's
black.
black, black. Yeah, I know.
We know. Yeah.
But can you please repeat the question which was being done?
Okay, I'll repeat it. Okay, so we had x square plus y square
Hello.
less than equal
Can
to
you
6.
just lift it up? Cannot see.
Okay, and you should be able
Yeah,
to
yeah,
see
it's fine. It's fine.
now.
Yeah, thank you.
Okay, okay, so we have x square plus y square less than equal to 6, and they are a non-negative integers. So let's start listing out all the possible combinations. So we have 0.
Where can 0 be there?
Yeah, 0 is a non-negative number.
Is the answer 4?
Okay, we'll
Yes, the answer is coming
check it out.
from.
Yeah.
So we have x 0, y could be 0 to 2. Now if we had x as 1, y could still be 0 to 2, right? Because 2 square plus 1 square is 5. And if we had x as 2, then we could have y from only 0 to 1. Because if we have 2 square plus 2 square, that's 8. And that violates our given condition.
Where video
Oh,
stop?
video has stopped. Your video is not visible.
Ahir, there is a network problem. We can't see you.
You are not audible as well.
Bhaiya, we could not hear you anything.
Ahir, we could
Yeah.
not see your solution. There was a net problem.
When you started, I think.
Acha, so
Everyone, please mute. Everyone, please mute.
you couldn't see the previous solution.
No, we are only starting, Bhaiya.
Here or C?
Okay, so we had x square plus y square less than equal to 3. And now we are
It's the answer 8.
we could have y from 0 to 2, right? Because 0 square plus 2 square is 4 and that's less than 6. If we had x as 1, we could still have y from 0 to 2 because 1 square plus 2 square is 5. And if we had x as 2, y could only be 0 and 1 because 2 square plus 2 square is 8 and that y-less are given condition. And x couldn't be 3 because then the sum would be at least 9. So in that case, we have 3 combinations from here, 3 combinations from here, and 2 from here. So it's 3 plus 3 plus 2, and that's 8. Now, is it clear why we are adding here and not multiplying?
Yes.
Okay, cool. So we'll move on to our second problem, which is this. So we have 4 cities, A, B, C, and D.
Ahir,
Now you have
shortlist হবে তো?
shortlist হবে বুঝতে পারছি না
Ahir, we cannot see
Doctor,
your
we can't
video.
see you.
can you see
Now we can. Now we can.
Okay,
Now we
cool.
can. Now we can
Okay.
see.
So we have 4 cities A, B, C, and D. Now, as you can see, we can travel from A to B in only one way. You can travel from B to C in 3 ways. And you can travel from C to D in 2 ways. So, how many ways can you travel from A to D by stopping at B1 and C1?
Can you repeat just once more?
Can you please repeat from by stopping at?
Okay, so how many ways can you travel from A to D by stopping at B1 and C1?
Is it fun? What is C1 and C1?
What?
What is B1 and C1?
Is the answer 60?
Is the answer 6?
Yes, yes, the answer is 6. So how are you solving this?
First, it
First, we can consider there are 2 ways.
Multiplying the number of stops, the routes between the 4 stoppages. Like from A to B there is 1, B to C there is 3, then into 2 between C and D 2. So we can multiply 3 into 2 into 1.
If we did not
Yeah,
stop at B or
exactly.
C.
So is it clear to all of you?
Yes.
Yeah, so the answer to this is 1 into 3 into 2, that's 6.
Would the answer change if we did not stop at B or C?
If we did not stop at B or C, so how do you travel from A to D if you don't pass to B and C?
Ahir, your camera is off, I think. We cannot see the
Again,
video.
right? I think it's got to do with my net connection. I'm not sure. Okay, you can see it again.
Yes.
Yes.
Okay, cool. So now we'll move on to अरे भाई की है. Okay. So you should be able to see. Okay, so moving on to permutations now. How many of you know what a permutation is?
I know.
It is the number of arrangements.
Okay, so I'll just say what a permutation is. So a permutation is basically
Let him
stop again. Okay. Okay, so a permutation is basically a rearrangement of n objects. Now let's take a set. Consider the set 1, 2.
Can you repeat the definition?
So suppose you have a collection of n objects. So a permutation is a rearrangement of these n objects. So suppose you have this set 1, 2, 3, 4, 5. So a valid permutation of this set would be 2, 3, 1, 5, 4. Because we are just rearranging these 5 terms, right? So basically this is essentially
The video was slow.
Dada, your video stopped.
Your video has stopped.
Connection.
I think he left the meeting and joined again.
Your Where did he go?
Ahir, are you here?
There are two Ahirs.
okay. Can
But we
you
cannot hear you.
okay? Can you
We cannot
hear me
hear
now?
you.
We can hear you, but we cannot see the.
Okay, now you can see and hear both, right?
Yes, yes.
Yes,
Okay,
yes, yes.
okay.
Now it is
My
clear.
connection went off. Okay, so a permutation is basically a rearrangement, as I said. So if we have this set 1, 2, 3, 4, 5, then a valid permutation of this set S would be say 2, 3, 1, 5, 4. Or if you took the name Kwani, a valid permutation of these letters would be say Tony, right? So this is a valid permutation of these letters.
Dada,
Yeah.
somebody has again started screen sharing.
अरे भाई. Okay, could you please stop it for the
If you are on a PC, use the floating window, or on a phone, just double click.
whatever.
So that's five. That set which had 5 numbers 1, 2, 3, 4, and 5. So it
Yeah.
may have 25 such
No,
arrangements.
It will
I'm
be
coming
5
to
for
that. Yeah. Yeah, it will be 5 factorial, exactly.
Yes, bhaiya,
So
5 factorial.
the number of permutations that you can have of a set. So suppose you have a set of n elements. Now, how many distinct permutations could you have of this? So for
N
to
Factorial.
visualize this, we'll have n blank. Suppose we have n blank. Now we choose one element from this set. Now we could place it in any of these n blanks, right? Okay, so suppose we placed one in this blank. Can you guys still hear me?
Yeah.
Yes,
Yes.
I can hear you.
Yeah, I hope.
Are you?
Okay, cool. Okay, so you can place this one in any of these n blanks, right?
Yes.
Yes.
Okay. Okay. Now, if we take another element, now we have n minus 1 blank remaining, right? So we could
Yes.
place it in any of these n minus 1 blanks. So the number of permutations till now is n into n minus 1. So suppose we fill 2 over here. Now we take 3 from here. We have n minus 2 blanks remaining. So we can place it in n minus 2 ways. And we continue like this until we fill up all the blanks. So the number of permutations that we had are n into n minus 1 up to 1. And this is n factorial. Right?
Can you repeat this once again, please?
Yes.
Repeat from the starting, please.
Okay. So we had an n element set, right?
Do we have
And we have a set of n elements.
elements?
Yeah, elements or whatever. Like you could consider n objects. You have n pens. Okay.
Okay.
Distinct pens. And you have n boxes. So in how many ways can you put the pens in these boxes? So suppose these are the n boxes that you have. Now the first pen you could put in any of these n boxes. So you could do that in n ways. Now we have one box left. So we have n minus 1 boxes. Now we take another pen from here and we can place it in any of these n minus 1 boxes. So we multiply it with n minus 1. Now we have n minus 2 boxes. So continuing like that, we get the number of permutations as n factorial. Here?
Yes.
Okay, cool. Now, moving on to a different problem, we still have n.
Sir,
Yeah.
please, from that part which you said n minus 1, that part I could not understand.
Yeah, so after we put the first pen in one of the boxes, that box is inaccessible, right? We cannot put another pen in that box. So now we have n minus 1 boxes, and if we pick a pen from here, we could place it in n minus 1 of those. And then the next pen, we could put in any of these n minus 2 boxes. Next one, we could put in any of these n minus 3 boxes. So if we continue like that, we get 1 into 2 into 3 up to n. Okay. So moving on to a different problem, we still have n pens. But now we have r boxes where r is less than n. So we have r boxes where r is less than n. Now in how many ways can you put these pens in these boxes?
Can you repeat the question?
N factorial by n minus 1 into n minus 1 factorial into r factorial.
Could you just repeat?
Okay, I'll repeat it. So we have okay, let's take a real life example. So we have n distinct pens. and we have R boxes.
How many boxes?
R. R is a number, any number less than n.
Answer is n factorial by n minus r factorial.
Yeah.
Okay, we'll get to the answer later on. So we proceed like the previous problem. So we have R boxes over here. Okay. Yeah. So we have R boxes over here. Now the first in this box, you could have any of these n pens. So put n over here. Now in this box, we already have put one pen in one of these boxes. So now we have n minus 1 element in here. So now in this box, we could put any of these n minus 1 pens. So we have n minus 1 over here. In this box, we could put any of this n minus 2. And continuing like that, this box will have n minus r plus 1 option. Okay.
The last thing you wrote in the last box.
This is n minus r plus 1. So this is box number 1, right? This is box number 2, this is box number 3, this is box number r. So you can notice that if you sum both of these, you will get n plus 1. So n plus 1, n plus 1, n plus 1, and here also you have n plus 1. So I hope that's an intuitive way of understanding why we have n minus r plus 1 over here. So if you multiply all of these, you get n factorial by n minus r factorial. And we also denote this by NPR. So NPR refers to the number of permutations of R elements chosen from N elements. Is it clear?
Yes.
Yes, bhaiya.
Okay, cool. We'll solve a problem on this shortly, but we'll move on to combinations now.
Ahir,
Huh.
when will the class end?
I think around 9.
Okay.
Okay. So moving on to combination. So if you have a combination, okay, so suppose we have the same set 1, 2, 3, 4, 5. A combination is basically any subset you take from this. So suppose 1, 2, 3 is a subset. So you could say that 1, 2, 3 is a 3 combination. Of the set A. So 3 combination refers to the fact that we have 3 elements in this set. So if you chose 1, 2, 3, 4, it would be a 4 combination of A. So what's the difference between a permutation and a combination? In a permutation, we had 1, 2, 3 and 3, 2, 1 as different permutations. But 1, 2, 3 and 3 to 1 are the same combination. So the order does not matter when it comes to combination. We'll try to understand this with a problem. So suppose you had 8.
The difference.
What?
With the difference between permutation and combination.
Yes. So in permutation, the order matters. Like the set 1, 2, 3 and 1, 3, 2 are different permutations. but 1 2 3 and 1 3 2 are the same combination. So in combination we check the list of elements. Like if in a box you had a red pen, a blue pen, and a yellow pen, you don't say that there are 3 factorial types of permutation. You say that we have just this set of elements like R, E, and what yellow pen. So in that case, RBY and RYB are the same thing, and we'll just see this with a problem. So suppose we have eight identical pens. So in how many ways can you select 2 pens from here? So could someone tell me the answer to this? I could hear you.
8 factorial.
28.
Factorial
Yes.
by, will it be 8 factorial by 8 minus 2 factorial into
Answer is 28.
factorial?
Yes, the answer is actually 28. So if we proceeded like our previous permutation based approach, we would have gotten 8. So we had n factorial by n minus r factorial for permutation. But here, suppose the pens are P1, P2, P3, P8, and we have 2 blanks over here. We are choosing 2 pens from here. So if we considered it permutation wise, we could have 8 combinations over here and 7 combinations over here. 10. So this would have given us 56. But we are counting P1, P2 and P2, P1 twice, right? But they're basically the same thing. If I choose pen 1 and pen 2, and if we choose pen 2 and pen 1, they are the same thing. So in general, we are choosing Pi, Pj, where I, J belong to 1 to 8 and I not equal to J. So we are choosing each of these elements twice. So we need to divide this by 2, and the answer is yes, 28. Is it clear?
Can you explain this?
Please explain this once again, please.
Okay, so which part could you not understand?
Two one.
Okay. So what we were doing during permutations is we were selecting 8 pens from here and then 7 pens from here. But here there is a difference from the previous problem. Here we are choosing from identical pens, and in that problem we were choosing from distinct pens. So in this case, if we choose the first pen and the second pen, and if we choose the second pen and the first pen, there is essentially no difference between the two. And that's why we are dividing the entire answer by 2. Now we'll be doing this in a more generalized form. So suppose we have n pens, and suppose we were choosing R pens from here. Choose R. So we can do it in a previous approach. We would have done it in NPR way. NPR, where NPR is equal to n factorial by n minus r factorial. But we are overcounting each combination several times. So if we take such a set, like suppose one of these R combinations is P1, P2, PR. We are overcounting this test, right? We are counting all the permutations of this R element set, and we are overcount. And how many permutations does this have? These are R factorial permutations. r factorial. So we are actually overcounting by a factor of r factorial. And hence we are dividing this entire answer by r factorial, and this gives us NCR. Okay, so we'll be moving on a bit faster now. If you have any doubts, you can read this from the handout. I have all of this written quite concisely. Okay, so let's.
By the way, is anyone recording? Okay, good.
Okay, let's move on to an RMO problem now. So yeah, that's quite the difficulty increase, right? Okay, we'll move on to an RMO problem in a bit. So
Hello.
yeah, just 1 minute. Okay, so this is a problem from RMO 2016. I'll share my screen in a bit. Wait.
Are you sharing your screen?
Yeah, can you see my screen now?
No, here.
No, we cannot.
No, it's not visible.
No, it's not visible.
Okay, just okay. I'll write up the problem if that's the problem.
Try again.
Yeah.
Or 6 digits.
Yeah, 6 digits.
Yeah, we can check.
We can see.
Ahir,
হ্যাঁ
is this an RMO problem?
হ্যাঁ RMO 2016.
তাহলে আমি কম্বি কিং।
হ্যাঁ সব হয়ে গেল হ্যাঁ
Allowed here.
Will it be
Yeah.
a 6 factorial?
Is the answer 2812 something?
Yeah,
281250 I got.
281250. And how did you get it? You can turn on your video and show your solution.
It is 50. We have to multiply 56 into 20 minus 55 into 10, which will give us 10 into 55 multiplied with 1. 10 minus 1, which gives us the answer.
Okay, so that is the correct answer, but right now we are more interested in the process rather than the answer. So let's try this. Okay, so can you see the whiteboard now?
Yes.
The answer.
Okay.
5c3 into 4c3 into 6 factorial.
Yeah, something like that. So basically, we have 6 blanks in this problem. We have 6 blanks over here. Now we'll divide this problem into 2 cases. In one case, we start here with an even number, denoted by E, and in another case, we'll start with an odd number here. So why did we basically did that to avoid the problem of 0, right? So if we start with 0 over here, it's a 5-digit number. So that's why we did this. So if we have E over here, okay, let's take case 1. Case 1, we start here with an even digit. So we still have 2 more even digits, which we could place in any of these 5 blanks. We could do that in 5 C2 ways, right? I am audible, right?
Yes.
Okay. So in these 5 blanks, we need to fill them with 2 even numbers, even digits, and we could do that in 5C2 ways. So we have 5C2, and now each of these,
Bhaiya,
yeah.
the video is not very clear. Actually, the focus of the video is not very clear.
Okay, what about now?
Now it's a bit better. Yeah, now it's a bit better.
Okay. So we selected the even spots here in 5C2 ways, and now we are multiplying that by this even number we could choose from 5 possible digits, right? So we have 2, 4, 6, 8, and 0. Sorry, we could actually choose in 4 different ways because we cannot choose 0 over here. So we have 4 possible ways over here, and in these 2 even numbers, we could choose in 5 ways and 5 ways. So that's 5 square. And the remaining odd numbers we could choose again in 5, 5, 5 ways. So we have 5 cube. And over here, we have odd, which is case 2. So we have an odd number over here. We could choose it in 5 ways. So we have the odd digits 1, 3, 5, 7, 9. Now we could choose. Now this could be any of these 5 numbers. So this is 5. Now these 5 blanks will be filled by 2 odd digits. And we could do that in 5C2 ways. And these 2 odd numbers could be any of these 5 digits. So we have 5 square. And the 3 even digits that we have 5 cube for that. Because they could be any of 2, 4, 6, 8, 0. So if you add this with this, we get the desired answer. Clear?
Yes.
Okay, cool. So
Could you please repeat once again?
Okay, sure. So we are dividing this problem into 2 cases. So when we are considering this 6-digit number, the first case is this place is filled with an even number, and here it is filled with an odd number. Now we still have 5 remaining spaces over here, which are going to be filled by 2 even numbers. We could do that in 5C2 ways. So we have a 5C2 over here. Now this even number could be anything from 2, 4, 6, and 8. It cannot be 0 because that will mean this is a 5-digit number. So if we choose it from 2, 4, 6, 8, it could be any of these 4. So we are multiplying this with 4. And now the 2 even digits that we have over here, they can be any of these 5. So we are multiplying with 5 square. And we have 3 spaces which are filled with odd numbers, which could be anything from 1, 3, 5, 7, 9. And they could be anything from these 5. So we multiply it with 5 cube. So this gives us something like 40 into 5 to the power 5, I think. That would be 8 into 5 to the power 6. And from here we should probably get something like 10 into 5 to the power 6. So our answer is 18 into 5 to the power 6. So could any of you calculate that and tell me the answer? I think it will be something like 281,250 or something.
281250.
Yeah, okay. Fine. Yeah.
Okay, thank you.
Yeah, so that was our first RMO problem. Pretty easy, right?
Yeah.
Okay, cool. Okay, so I don't think we have time to teach two more topics. So we'll move on to double counting now. So double counting is a very interesting tool which we can use to solve various problems. So how exactly does double counting work? Uh, the term itself is actually quite self-explanatory. We are counting something in two ways. So try proving this identity. We have n is 0 plus n.
I can't
Sorry,
see,
sorry.
Bhaiya.
One second. You can't see?
Bhaiya, it's too easy.
It's hazy.
Is it more clear now?
No,
No.
it's same.
What about now? Okay, no, it's not easy.
No.
No,
When
it's
we
the
leave it,
same.
let's see
Same.
which else.
So you can't read what's written on the board.
No.
No.
It's hazy.
It's easy. Okay, let me move it up a bit. What about now?
Same.
No.
Same. Bhaiya,
Okay.
you can use the whiteboard of the WebEx.
Okay, yeah, I'll move on to that. It's a bit tedious, but I can move this.
Hello?
Ahir,
Bhaiya?
I think he cannot hear us, or we cannot hear him. Ahir, the meeting will end in 5 minutes.
Will we join again?
Yes,
Okay, Bhaiya.
Bhaiya, can you please tell till how much the class will be going on?
around 9 p.m.
Okay, thank you.
আহির
হ্যাঁ
ওই আরএমও কোশ্চেনটা কি তোর হ্যান্ডআউটে সলভ করা আছে?
আমার কোশ্চেনটা হ্যান্ড আউটে সলভ করা নেই, আমি পরে পোস্ট করে দেবো।
Bhaiya, we could not hear you in between. What did you say? Did you write the identity?
No,
No,
he did not
I
do
haven't.
it.
Hello.
Hello, yeah. Can you hear me now?
Yeah, Bhaiya. You can
Yes.
only also tell the identity.
Yeah, we can hear
Okay,
you.
so can you see the screen board now?
Yes.
Bit more.
It stopped. Video has stopped.
Yeah, stopped.
I cannot see a board.
Okay, now?
Now I can see a board. Now
We can see.
also.
Okay, cool. So try proving this identity. So we have NC0 square, that's N choose 0 square. Plus
What N?
NC0, like choosing 0 objects from n things. We write this as NC0, like I showed you, right, that we NCR is NPR by R factorial
NC0 square
plus NC1 square up to NCN square. This is equal to 2NCN. Can you prove this?
Repeat the identity because it's not visible clearly.
Okay,
NC0 square plus NC1 square plus so on till NCN square equal to 2NCN.
Okay, give me a second. I'll be back with my charger. I'm running out of charge.
Yes, I can prove it. Like, will I say the answer? Like, will I say how to prove it?
It will be
Sure, go
something
ahead. Go ahead.
NC0 equals to 1,
Actually,
NC1 equals to n,
mm,
and NC2 equals to NC2n in the bracket n1 by 2, and then
actually, NCR is equal to NCN minus R. So,
Okay, am I?
The camera is rotated 90 degrees.
Yeah, I think so. Okay, so now
হেজি আসছে।
দেখা যাচ্ছে।
তুই লিখেছিস কি? শুধু দেখে মনে হচ্ছে দুটো লাইন আছে।
দেখা যাচ্ছে। পড়া যাচ্ছে?
না।
এবারে
it is showing low bandwidth.
The video is loading.
Okay, what about now?
Video is buffering.
Video is buffering. I can see your video. It's hazy now.
I found how to solve this question.
Okay, so you guys have understood what the question is, right? It's NC0 square plus NC1 square. Yeah. Okay, so consider this. Suppose we have n distinct black balls and n
Still loading.
distinct white balls. Okay?
You all please hear to him carefully. Like in
Yeah, yeah,
combinatorics, the logic matters more than the writing.
yeah.
The writing
Okay,
is just addition and multiplication. If you can follow the logic, you can solve it yourself. So please listen
Yeah.
to him carefully.
Okay, so suppose we have n distinct white balls and n distinct black balls. Now, in how many ways can you choose n balls from here? It's obviously 2ncn, right? By the definition of what NCR is. Clear till now?
Anyone has any doubts?
Why I could not understand.
Okay, so suppose we have n distinct white balls and n distinct black balls. So a total of 2n balls. And you're choosing n balls from these. So you can obviously do that in 2ncn ways, right? Because that's the definition of what NCR is. Choosing R objects from n of them.
Yes.
Till now?
Yeah.
Okay.
Ahir, we cannot hear you.
Now, what's NC n minus R? It is n factorial by n minus n plus R factorial, n minus R factorial, which is n factorial by n minus R factorial, R factorial. So basically, NCR is equal to NC n minus R, right? I hope I'm audible.
Yeah, yeah.
Okay.
Yes, you are audible.
So
Yes.
NCR is NC n minus R. Clear till that?
Yes.
Okay. So suppose we choose n black balls and 0 white balls. We can do this in NCN, meaning we choose n balls from n black balls. We can do this in NCN way. And we are choosing 0 white balls from n white balls. We can do it in NC0 way. Right?
Yes.
Okay. This was case 1. Now case 2 is we choose n minus 1 balls from n minus 1 black balls and
Bhaiya, we cannot hear
You're
you.
not audible.
You have muted your mic.
okay, what about now?
Yeah.
It's okay.
So the second case is we choose n minus 1 black balls and 1 white ball. Now we can do this in NC n minus 1 into NC1 way. Right?
Dada, can you just repeat?
Yeah. So our second case was we are choosing n minus 1 black ball and 1 white ball. I got muted again. Okay,
No,
can you
we
hear me
can't.
now?
We can hear you. We can hear you.
Okay, okay. So we can do this in NC n minus 1 into NC1 way, right? Now we'll take a general case. Suppose we choose k black balls and n minus k white balls. So in how many ways can we do this? We can do this in nck into nc n minus k ways, right? Now we have already shown that ncr is equal to nc n minus r. So nck into nc n minus k is basically nck whole square. Now if we take all these cases and we sum them, what we are getting is nc0 square plus nc1 square up to ncn square. And from a different point of view, it was also 2ncn. So basically we counted this two ways to prove this identity. So any questions?
Can you give some problems to understand these more?
Okay.
So everyone
the-
follow
the-
this example, right? Everyone could follow this
Bhaiya, when you
example.
will send the handout where there will be solutions to the questions given.
No, only the question.
Yeah, okay. So which part could you not understand here? So
Dada,
you've
are we
understood.
learning combinations?
What?
Are we learning combinations? Actually, I joined just now.
The class will end in like 5 or 10 minutes. So, yeah, that's what we are doing.
Okay. We will get the handout after this.
Yeah, you'll get the handout. Okay, so double counting, right? So you guys understood the problem, right? That we have to prove the identity n 2ncn is nc0 square plus nc1 square up to ncn square.
Yeah.
And we took this example of n white ball and
Ahir,
n black.
Ahir, are you solving it again?
Solving it again মানে যদি কেউ না বুঝতে পেরে থাকে তাহলে
মানে আমি লিখবো আবার?
হ্যাঁ একটু লিখে দে তাহলে।
মানে সেম জিনিসটাই তো?
হ্যাঁ
ঠিক আছে।
মানে in case anyone didn't understand this, সবাইকে ছেড়ে চলে গেলাম নাকি শুনতেই পাচ্ছি না।
আরে বল স্পিক।
আচ্ছা, okay, so by the definition of what NCR is, we got that we can choose n balls from n white and n black balls in 2ncn ways. And now case wise, when we look at this, so the general case is we take k black ball and n minus k white ball. So we can do this in nck into nc n minus k way. And we have already proved that nck is equal to nc n minus k. So that is basically nck whole square. Now the first case is 0 black balls, the second case is 1 black ball, and continuing like this till n black balls. So k varies from 0 to n. So our sum is from 0 to n nck whole square, right?
You are not audible.
Okay, can you hear me now?
Yeah.
Yes.
Okay. So till what could you hear? Okay, yeah, Kwan is writing that, so you can just. Okay, so now have you understood what this is? Okay, yeah, don't use sigma. They don't know what sigma is. So sigma is basically, we are summing this from 0 to n. So nc 0 square plus nc 1 square, it's just a fancy way of writing that.
So anyone has any doubts in this example?
Yeah. अच्छा करो डाउट नहीं डालो.
I think no.
No.
Okay.
Everyone understood this then. So Ahir, do you have anything else to teach today, or is it over?
So if we could take this till 9:10, so could you guys spare 10 minutes more?
Yeah, sure.
Yes.
Okay. So we can do our IMO shortlist problem now. We have enough knowledge to actually at least
Yeah, we can
approve
do.
it.
Ahir,
Yeah.
please share your whiteboard.
That.
Webex whiteboard.
Yeah. I'll try to find my
Will we get
assignment.
that recording of this class?
Uh, yeah, I hope someone recorded it, but I don't know.
Like, will
It is
it
going to be
be
after.
with voice or not without any voice?
I'm not sure. You'll have to ask whoever's recording this. Okay, yeah. No, my net connection is really terrible today, so hopefully next time it will be much better. Okay, so I'll just share my screen. Okay, so can you look at question 4.6?
কিছুই তো দেখা যাচ্ছে না রে।
It's not visible.
We cannot see
But
this.
your whiteboard is not visible, bhaiya.
Okay, I think it's because of my net connection. One second. Can you see it now?
No.
No.
So what can you see?
Yeah, Ahir, which
Ahir is starting to share content on a black screen.
Ahir, which year and which question?
2004 C1.
ঠিক আছে।
Oh, sorry, 2014. Sorry, it is 2014.
You all can see my screen, right?
Yes.
Yes, we can see.
C1
gone
to
ahead.
Ahir.
Huh?
I cannot see any screen.
C1 না C4
C1
কি
to
বললি?
C1 2014.
হ্যাঁ 2014 সাউথ আফ্রিকা।
দাঁড়া আমি দেখতে পাচ্ছি না কোথায় তোর ভিডিওটা কোথায়?
স্ক্রিন শেয়ার করছি তো। হ্যাঁ
দাঁড়া ভাই আমারটা একদম জালি হয়ে গেছে। Acha, I'll try to share my screen again if it works. Okay, can you see it now?
No.
No.
Now we can see.
Yes, now we can see.
Okay,
So
what
read
about now?
problem C1. আহির আমি শেয়ার করেছি
আচ্ছা ঠিক আছে তাহলে তুই দেখা
সলভ করিস
Okay,
তুই হ্যাঁ আমি পারবো না এসব
okay, sir, just go through the problem once. Okay, so is it visible now? So once all of you have gone through the question, let me know one.
It's not clearly visible.
Okay, you can't see what I written.
No, we cannot see.
Okay, I'll write a little bigger then.
Or
Can you read now?
or you can just tell it orally.
I should leave the
Hey,
Sorry,
1
not
plus
audible.
1 3 I can see 1 plus 1 3
Okay, you can see 1 plus 1
Yes,
3, right?
even me.
yes
Okay, so it's visible. Right? So let me know when you've gone through the problem and we can start solving.
Screen is hazy.
You can't see my screen. Okay, I'll-
Now it's just showing Ahir is starting to share content on a black screen.
Okay, so can you see the whiteboard now?
Yes, we can see the whiteboard.
Yes.
Okay, cool. So do any of you have any approaches to this problem? Uh, any idea on how we could, it's not exactly a solution, but how we could start off?
Isn't this a geometrical problem?
Not really. I mean, we do have a rectangle here, but other than that, this is a combinatorial problem. Okay, so let's try to solve it. This is a very simple problem actually. So let's okay. Now we have a box, a square, and we have n points inside it. Right?
Ahir, are you writing something?
হ্যাঁ পড়া যাচ্ছে না?
না, পুরো
Not a
সাদাই তো
single
আছে।
dot we can see.
বক্স দেখা যাচ্ছে না?
Nothing.
আমি তো আঁকছি দেখে কিছুই দেখা
Now we
যাচ্ছে না।
can see.
Okay, so you can see this square, right?
Yes.
Okay, so we have n points inside this. At least how many lines do we need to draw to satisfy the given condition?
For anyone who forgot the condition, you can read the question again quickly.
Question number
1, C1, C1.
Okay, so here's something we can do. So you guys can try this problem on your own, and so can we conduct a session tomorrow?
Could it be means next week? Means in this not tomorrow means
Ahir,
after
Ahir, আমরা
Monday, Tuesday.
একটা প্রবলেম
হ্যাঁ বল।
সলভিং সেশন কন্ডাক্ট করতাম ওয়েডনেসডে বা থার্সডে করে।
আচ্ছা
তো
না
তো মানে এই উইকের যত যা প্রবলেম দেখানো
আচ্ছা
Solving sessions on Tuesday.
date and time have not been fixed yet, but it around
না
Tuesday
এখনো
or
ওই
Wednesday or
ইনক্লুশন
Thursday.
এক্সক্লুশন আর কয়েকটা জিনিস বাকি আছে।
হ্যাঁ তাহলে কাল
Yes, tomorrow.
Tomorrow, yeah, we could have like one or 1.5 hours.
So if anyone cannot attend it, so please read the handouts
Yeah.
and watch the
All of this
recording
is
if you
written
can.
in the handout. I haven't solved a lot of problems there. I'll probably do a handout on that too. But the basic theory of what I said is all in there. Permutations, combinations, when to add, when to multiply. You will find all the examples. আচ্ছা তাহলে এখানেই শেষ করা যাক।
Anyone wants to say anything?
Does anyone have any questions on what we covered today?
So we are ending the meeting then.
Thank you.